guys, so today you and I are going to talk about CORS and event sourcing and distributed systems, so let's get into it. So what we're going to cover is basically what is CQRS or CORS and when can it be useful. Then we're going to also talk about event sourcing and how it can help us in a microservices architecture. So the question in question that kind of spawned this whole video was, thanks a lot for sharing this video. It was very useful. Can you make a video implementing CORS, event sourcing, RabbitMQ, and microservices? Because I have read a lot of DDD and CORS, but I've never seen a real project example. Now this is a big ask. I'm gonna be honest with you. It is a very complicated topic that we're touching on, but I'm going to show you, at least from my perspective, how CORS can be implemented in a way that makes sense and how we can use event sourcing together with this concept to create as part of a microservices architecture. So let's start with this simple stuff first and foremost. We're gonna just gloss over the basics. Command query responsibility segregation, or CORS, is basically just an application structure. Now what it is about is in essence that you formulate all of your reads and your writes into queries and commands. And the difference between these two is that a query is something that is going to return data from a database or something like that. It's a GET request 99.999% of the time. A command is an update. It's something that you are writing to a database. It's something that you're writing to the system. Now, the reason why you want to separate these two things is usually because one is happening more than the other, or one operation is more heavy than the other. And that is where CORS comes in. In a normal application situation, all you really want is a layered architecture, which is that, all right, the same server is dealing with both reads and writes. That's very normal. That's standard practice. CORS only really becomes powerful for most cases when you have, as I was saying, there's a big difference in a read or a write, or there's a requirement on performance. And basically that is expressed in this fashion. So let's say, for the sake of argument, that I have this application here. I have a auction application API, and it will take bids, and it will also show the most current bid. So if we look at my little application here, we'll see here that it's an Express server, and here I have a GET where I get some bids, and in this case I'm going to structure it like this. I'm going to say get highest bid query, and this is a query, and then I'm just going to log out so that this makes sense to us. What's going on here, getting highest bid. And then I have a query service that is going to run that query, and then it's going to return me a bid, and then I'm going to return that bid to the client. Now I also have a post where we can place a bid. So here I just send a number, and it's going to set a currency for me and just parse that into an amount, and that's going to create a bid. And then I'm going to create a bid command, and that command is then going to do this, and this is me simulating something. Now let's pretend that let's think about it conceptually. If I have a bidding site, there's going to be a lot of reads. Like, people are going to check the number. What is the current bid? What's the current bid? All the time. If it's a big auction, they're going to want to know that all the time. So the placing of the bid is going to be slightly slower, because people are going to want to know what the highest bid is more than they're going to place bids. And in this case, I simulate with a wait function like this, where I create a promise, I set a timeout, and then I just delay this thread or this promise a little while by 2 seconds. I'm just trying to simulate that this operation is slow. Because placing a bid, let's say for the sake of argument that the logic that we had here was that, oh, no, you need to do a lookup on that person who's placing this bid. Maybe they don't have the money or something like that, and that's going to take some time. So what we want to avoid here is that all the people who want to see what the bid is get blocked by this request. Because as you can imagine, this is going to be slow. It's going to take a while. So we don't want the people who are placing bids to block the people who are going to want to see what the bid is. So that is the basic structure to all of this. So if we have a look at, say, get highest bid query, it's just a class that has a common interface, and in this case I decided that the method that I'm going to have is called the run function. So every query, regardless of which query type it is, will have the run function, and internally this query knows how to actually execute the logic that is going to be associated with this. And then I have a store service, and the store service is just this service here, where all this does is that it is going to store the data, like it's going to store to the database. Now this is using event sourcing, and we're going to touch on that in just a moment, because I feel we have to chip away at each layer of this question, because it's so big that I could have made 3 different videos about it. So then we have the command. Now the main difference between a command and a query in traditional course philosophy is that a command does not return anything. A query always returns something, and there's a reason for that. So this is how I structure the command. I take in a bid, I place it here, and when we call the run function, we're going to create a ID, and then we're going to create a bid, which is just, in this case, this is just a model. It's just a let's see here, create bid. I think it's in here, right? Yes, here. So as you can see here, it's really only it's just an object. And once we've created the bid, we're going to store the event, which this is a bid event, and then we're going to store those events. Once again, just bear with me, this has to do with event sourcing. So once that's all good and done, we're going to have, if we have a look at the application here, you're going to see that the command service here, the run command, this is an asynchronous operation. But we're not awaiting this. We're waiting up here, but we're not waiting down here. And the reason is very simple, because we don't want the client to block the thread unnecessarily. We just want the write to happen as quickly as possible, and we're just going to assume that it's going to work, because this is a heavy operation. We don't want to return something and keep the connection alive when we can start serving new connections. That's the foundation idea here, guys, that I want you to take away from the course part. Course is designed to make it very easy and fast to write to the system on one application, or in one for one set of commands, and the other part of it is that you want to separate out the querying. So how do we do this in practice? Well, this is in the same application, so if I have one instance of this application, that's not going to help me all that much, so I need to separate this somehow, and that's what I've done through Docker Compose here. So I'm using Docker here, and there's a ton of stuff here, but let's just walk through it really slowly and focus on the stuff that is most important for our current context, which is the course part. So I have an Nginx instance, and this is very important. In order for me to be able to separate the people who want to read and find the latest bid from the people who are going to add a bid, I need to create 2 applications. I need one application that's dealing with one, or many actually, but one application that's going to deal with the posts, and one that's going to deal with the gets. So I create an Nginx instance, and this is going to depend on the place bids application and the get bids application. And then down here I have my place bid application, which is just going to be named place bids, and it has a reference here to MongoDB. They're using the same database. Now, this is also an important factor to consider. If I have the ability to fetch both, or to run gets and posts as quickly as humanly possible on 2 different applications, I might have 30 versions of placing bids and maybe 100 versions of get bids. The main bottleneck here is the database. That is a separate video where we would have to talk about how to deal with performance optimizing a database for a distributed system. But you should be aware of this, that in this scenario the database might actually become the bottleneck, and then it doesn't really matter how many versions of the application you have, because the database just can't keep up with all the queries and the commands. And the same thing goes for the bids. So getting the bids, No, nothing special there. It's the exact same application. It's just two different instances of the same application. And down here I have my database. So if we now look at my Nginx configuration, this is how simple it is. All it's doing is that when I go to my Nginx instance, it's going to take every single route, and it's going to check the method. If it's a post, I'm going to send it to place bids. If it's a get, I'm going to send it to get bids. Pretty straightforward, right? What this now has done is that it has made sure that the people who are placing the bid are not blocking the people who are getting bids, because they're running on different resources. And I can scale up this part, or I can scale up this part as much as I want, so that if my posts are taking too long, and then I need to add more boxes, but if my gets are taking too long, or maybe they're not under as much load anymore, then I can reduce the amount, even though the posts are still really heavy. So that is the foundation idea of CORS. Now, the second part of this is, how do we tie event sourcing into all of this? Because event sourcing is a different sort of topic. Now, you can use CORS without event sourcing, and you can use event sourcing without CORS. What makes it very nice to use event sourcing as a part of a distributed system, though, is that event sourcing is about events. Go figure, right? It's about events. And instead of using what we call a model, which is this thing that you probably know as this record that you have in the database. It's the data that you have stored after something has happened. We call that a view. And a view is it's the same thing as a model, but the way that we create it is different. The way we create a view is not by just instantiating an object, adding some data to it, and then pushing it to the database. No, we create an event that represents what we want to do, and then we pipe that through a so-called reducer or a function that knows how to apply the mutation that event represents to the view. So an example would be that instead of just instantiating an object and saying, hey, this user here, he or she should have this name or something like that, we would create a create user event. Or maybe if we wanted to update the name, we would say update user name. Or if we wanted to delete the user, we would say delete user. And then we would simply run that query. No, sorry, not the query. We would use this event in order to perform the operation. And I'm going to show you an example of this. So what's powerful about that is that you store all of these events, what's cool about that is that this is append only. So it becomes like a ledger of transactions, where if you want to know what the view looks like, or let's say that I, for some reason, have a database outage and I lose all my data and I still have the events, well, then I can just replay all these events one by one, and I will be left with the same database state, because I have stored all the things that has happened in order to get to that place. It's very similar to how you would apply a database migration in a relational database. Cool. So let's now have a look at my bid service here again. And let's take a look at these events here that we were looking at earlier. So I have, as you know, I have this store service. So let's start here. So a store service is just an abstraction on top of the logic that is needed in order for me to create a view. So what I'm going to do here is that I'm going to have a set of reducers, and for the people who are using Redux and events, stuff like that, this may feel very similar, because event sourcing is very similar to how Redux works with reducers. So when I have a sequence of events here, what I'm going to do is that I'm going to go through all the events, and I'm going to save the event itself. And that is very important, and we will see later why this becomes so important. But you already know right now that an event is just the thing that represents what's going to happen. So when I'm creating a bid in my application up here, in my create bid command here, let's actually go directly there. I'm losing track here. I'm creating this event here, the create bid event, and this event here is just going to have a label type. As you can see, I have a bunch of event types, and this is the create bid event type. And then I add the data that this event needs in order to do this operation. So creating a bid, well, a bid just has an ID, an amount, and a currency. That's it. That's the entire bid, right? And I create an event that holds that data. Hope you're with me so far. Once I have done that, I send it to my event to the store. I can send one event or I can send many events. It doesn't really matter. And then I try to see if there is a view model, like in other words, a finished state or a model that represents what the bid should look like first, because it might be that this might be an update. Maybe I'm not creating a new bid, I'm just updating something or in something in line with that. So I check, do I have a view that already exists? Okay, if I do, well, okay, then I'm going to extract out all the information from the event, and then I'm going to run all of my reducers over this event and this view. That's it. It's literally the same thing as Redux. It's just a pure function, and we can look at my reducer. We have a bid reducer. So this is my bid reducer. And if you just substitute store and action, and call this action, or like this is the reverse now, but the event is the action and the view is the store, or the state of your application, then for those of you who are familiar with Redux, it's the same thing. So I'm just checking, what is the event type? Okay, the event type is create bid. All right, cool. Then I know that I'm not going to do a mutation or something like that. Usually, had this been an update, I would have checked, okay, I have a view here, okay, and there's an update to this bid, or maybe we're going to change something about it. Then I would perform the update here and return the new state of my view. That's it. And if this event doesn't match any of the types that I've declared, I'm just going to return the view as is. That's it. So it's just a pure mapping function, if that makes sense to you. Now, once I've done this, I'm going to be left with this new and updated view. And then I just have to store it to my database. Easy peasy. So now I'm left with the updated view in the database, the model that I'm going to send to my users or when they're querying for stuff, and a registered event that is going to show me that, oh, at that moment in time, I did this operation, just like a log. However, if there is no view in the database, that means that I'm creating it from scratch, and then I just directly go into mapping over all my reducers, and then I save the view. And then at the end of all of this, I'm just going to go and grab the last event that I had in my list, and I'm going to go and find the end view. And I'm just going to go and get the view once all of this has been applied, I'm just going to go and get the view from the database and return the view from the database. And that is pretty much the basics of what event sourcing is about. Like, all you have to really take away from this is that you have a view which is exactly like a model. It's just that it gets created through a pipeline of events. You apply the events, and then you're left with the end view. Now, why is this such a big deal for a distributed system? I'm very glad that you asked. This is a big deal for a distributed system because one of the biggest problems with distributed systems is that if you, let's say for the sake of argument, have one application such as this that takes care of all the bids, and then you have one application that is depending on knowing that something happened in this application. How are you going to solve that? Well, some people would say, oh, well, Frederick, that's very easy. I mean, as soon as somebody places a bid, I will just send a network request to my other application and say, hey, this happened. So this bid has been placed. Hope you know about it. And sure, you can do that. And in many cases, that's going to be fine. But what happens if something happens with the network? Someone deploys some faulty code, or maybe the internet goes down, or one of those environments goes down. Well, then you're going to be in a so-called inconsistent state. You're going to have your bidding application that knows all the bids, but the other application doesn't know that these bids have been taking place. So how are you going to fix that? Well, you can connect it to a database maybe, and hopefully you're going to store all the events or like all the data that is needed for that other application to get what that application needs from your bidding application. This is where event sourcing becomes really useful, because if you're dealing with event sourcing, you are already storing all the events that have taken place in the bidding system, which means that if another system wants to know, or let's say that something happens and for a little while that system can't connect to your bidding system, Well, it doesn't really matter, because as soon as that system is up again, it can just go and check, okay, when was the last time I got some data from the bidding system? Well, I'll just go and check for the events in the event store and check it out. I now, because there's a log, or there's a history of all the things that have been happening. You're not just left with a model that could have changed 100 times without you knowing what changed in between each change. That's what's so powerful about event sourcing. And if you're now going to deal with an efficient way of communicating that, oh, something happened in system A or in the bidding system, and you want to communicate that to another system, a queue, and this is why this person is asking about it, is a very natural way of doing that. And event sourcing is so powerful to use with the queue, because it's exactly what a queue is about. A queue is about taking the fact that something happened, an event, and communicating that to another party. So what I've done here is that I've hooked up all of these services to a so-called dispatcher. Now, you don't have to do it this way. The reason why I'm creating a dispatcher is because I want to solve one fundamental problem, and that is that I don't want a push-based solution for my events. As I was saying, because if the bidding application has to, let's say that I just added it would be so easy for me, so easy to create here, on this line here, literally right here, to create a network call to state that, hey, the bid took place, hey, the bid took place, as soon as somebody saves a bid. That would be very easy for me to just dispatch that out. But one thing that's going to happen then is going to slow down my bidding application, and I don't want that, because as we were saying, we're trying to optimize for performance here, and we can't do this. So what I want is an asynchronous way to communicate that, hey, this bid took place. But I also don't want to find myself in a situation where I, by accident, miss out on events because of some network communication problem. So instead of having a push-based system where the bidding application is pushing information to another system, I want a pull system. I want the other applications to fetch the event information from my main application. And that's why event sourcing is so powerful, because I have stored all the events. It doesn't matter if the data is inconsistent in the other system. It could be a year of downtime on one side, and as soon as that system is up, they just have to go through all of my events in my data store, and they now know what's happened in the bidding system. So here is my dispatcher. And the dispatcher is literally just a RabbitMQ client and a Mongoose client or a MongoDB client and this is a script. It's not even a server, because it doesn't have to be a server. It's just a process that's going to live inside of a Docker container. So what I do here is that when I call the run function, I'm just going to instantiate the connection and a channel to a RabbitMQ. And then, of course, I'm going to check if I have a connection to MongoDB. I have to do this so that if the data, because when I'm spinning up all of these boxes, and we're going to do that as well, I promise, the connection may not work on the first try. It might have, I need a few retries sometimes. And then I have my event dispatch service. So let's have a look at my event dispatch service. So the event dispatch service is as simple as this. All it's going to do is it's going to find the last dispatch event. So it's going to go and find one, and it's going to just check, when was the last time I sent out data to RabbitMQ? Because I don't want to unnecessarily, and this is a risk, you should know about this, because it's always a risk when you're dealing with event-based systems, that you send the same event twice. So your consumer system, such as the system that we're going to look at last, is always it has to be aware of that it might get the same event twice. It's there are ways to solve this, but that's a much more complicated topic, and I'm not going to cover that. But it can be solved. And then I can store the latest dispatch, so I know that, oh, this was it's like a pointer. Oh, I sent all of these events, and now I'm going to wait, and then I'm going to poll in another 5 seconds, because the timer is 5 seconds. And then I'm just going to repeat this process whenever there's something new to send out to the other systems. And here I'm just going to find the bid events. And this is me going through all of the events that I've stored in the store service, and just finding whatever event is older than the last time. And that's it, or newer than the last time. And here, the model is dirt simple. It's just created at, and then I just declared a queue, and I'm gonna show you that as well, what a queue is all about. And here is the data that I'm sending as part of the dispatch. Now, this is an important philosophical thing that is open for a lot of discussion for many people. So some will say that, all right, if there is an event and I could just use the event sourcing event that was part of my event sourcing in the bid application and send that as raw data. I don't think that's a good idea. You can do it. It's not bad necessarily. It's just that I think that it's much more efficient for you to allow the events that are going to be placed on your queue so that the other systems can pick it up to be in a normalized structure, because that means that it's easy for other systems to consume what you're sending. Because if you're just sending the raw model that's in the bid system, then that's open for change. And if you create this layer in between, it becomes like an interface. It doesn't really matter if the underlying mechanics of the bid application changes, because the interface of this event is always going to stay the same, and it becomes much easier for other applications to consume it, right? So, continuing on, now we're dealing with the bid events, and all we're going to do is that we're going to assert that we actually have a queue. We've connected to the queue with this, which is going to be the bids queue, and then we serialize, or we stringify our event. So we're just going to create a bid dispatch event, and we're going to just grab all the data from the events that we've read. We're going to convert that to a buffer, and we're going to send it to the queue. And now we've sent it to RabbitMQ. So this is now this dispatcher done pretty much, and then it's going to do the same thing as I was stating earlier. It's going to just store the last time it ran this job, and then we're going to create an interval, and we're just going to run this every 5 seconds. So every 5 seconds we're going to go, are there any new events? Are there any new events? Are there any new events? And just endlessly, and communicate that to RabbitMQ. And then some other application can consume this information. So I'm going to spin up. We're just going to do this. And we're going to start up all of these applications just so you can kind of see this in action. Because I know that there is so much information going on now, and this is, honestly, as I said, this person who asked this question was swinging for the fences with the question. This is like asking, Frederick, can you please teach me everything there is to know about infrastructure? Well, not necessarily, but it is that big of a question we're talking about here. I should have maybe made this into several videos, because that is how tricky it is. So now RabbitMQ is up. As you could see there earlier, it took a while for RabbitMQ to go up, and I don't want my dispatcher should not be crashing. So it's just, and the same thing with my admin application, which is the last application we're going to look at. So the dispatcher took a little while until it actually got connected, and that's when RabbitMQ is now up and live. So now you'll see here that every 5 seconds, my dispatcher is going to tell me that, oh, new events found, 0, running dispatch. Oh, it's going to run the dispatcher, and it's going to say 0 events. Now, if I, on the other hand, go and do something like I've been doing so many videos now, I think I have it here, right? I think that's the one, right? Yes. So now I placed a bid, and you see that the connection took a little while there. If we just go through the logs here, you'll see that it said, all right, there's the connection. So this is a post, and which means that it's going to go to place bids. And here is the log that states what I sent. Notice that it took 2 seconds, and it's because of that little wait function that we had, right? And then MongoDB is going to kick in and say, hey, I have a connection here. All right, I'm going to store some data. And then the dispatcher is going to run and say, hey, I'm running the dispatcher. Here are the new events. 1. And then it's going to say sent message, source, place bids, yada, yada, yada. Here's the data that I just sent. And that's the whole story. And then my admin system, which is the last system, which is this external system that needs this information somehow, is going to say, oh, I see here, because it is connected to RabbitMQ as well. It's going to say, hey, I saw this information here, or like I got that information from you. So if we look at the admin system, which is the last part, I promise, it's this application here. So all this system is doing is, let's just pretend that this is an internal system. It just wants to know if there's a bid so that it can check if this is a really high bid or something like that. It can be many other things. There could be metrics that it's gathering, etc., etc. But this is, let's just pretend, an internal system that it doesn't really matter in this scenario if the data is real time. It's not like our users who are using the get bids application, because they want to know all the time, frequently, like what is the bid, what is the bid, what is the bid, like ideally with like millisecond precision. This system doesn't care. This just wants to know if something really big was, like a big bid was placed, so that, I don't know, the marketing department can go and check if this person really has the money, or if this person should be on some VIP list. So the admin service is also, like, it's a very silly little service. All it does is that it checks if the bid amount is over 10,000, and then it stores this directly. This is not using event sourcing because it doesn't need to use event sourcing. So that is this entire system, and here is the listener. And I just connect this up next to, no, this is the dispatcher, sorry. I can't believe that my voice hasn't given out yet. But hey, I'm getting resilient from making all these videos. Here it is. This thing here is now connected, and it's connected to the RabbitMQ server. And it's just going to, I've just created an initialization script here because for some reason they decided that the client for sending information is actually going to use Bluebird, and the client for consuming information is not. I don't know why. Don't ask me. That's how it works. That's just how they roll. So we do the same thing. We have a run function, gets a channel, asserts that we actually have the queue, and then it's just going to, in this case, it's just going to log out that, oh, I got this message, cool. And then we're going to parse that message into JSON and add it to our admin system, admin call. And we're also, of course, going to run this on a loop, but this doesn't have to poll or anything like that. So as you can see here, we're actually going to clear the interval if we have a channel. So if there's no channel, we're going to continue until we get a channel. And when we have that channel, we're just going to kill this interval and stay with that channel. So I took the liberty of just exposing RabbitMQ a little bit here. Was it 8080 or 8081? No. Let's go and actually go to my Docker Compose file. RabbitMQ, it's 8082, of course. So here, this is just me showing you kind of the triage now. So you can imagine it, this is the queue itself. This is a RabbitMQ in essence. And what you can see here is that I have two channels, and these two channels are representing my get bids, or my bidding application, and my admin application. I hope that's clear to you. The admin, the reason why I want to do this is because I don't want this communication between these two systems to be synchronous. I want it to be async, because the admin application should not block the performance of my other system. I could have put on more client listeners to this system so that more systems could be informed of events and so forth. And that's where this powerful, like the power of a event-based distributed system comes. So if I look at my queues here, I see here that I have a bid queue, which is super nice, and I can say I get the message, okay, the queue is empty, because yes, I have already consumed the message, sorry about that. But I can even push messages and stuff like that. This is not a story about a RabbitMQ, but I just want you to understand that this is just a separate application, an off-the-shelf solution that is provided that takes the incoming message from the dispatcher, puts it on a queue, and then when the consumer application, such as another system like the admin application, is good and ready, it fetches that information. So what I want you to take away from all of this talking that I've done is that this sort of question is absolutely monstrous, and I've just given you a little basic crash course into the benefits of CQRS, the benefits of event sourcing, and kind of what these two things are, and how these things can fit in together into a distributed system. Event sourcing is possible to do without CQRS. CQRS of course, is possible to do without event sourcing. They are not exclusive. The same thing goes with the event queue. You don't have to use event sourcing in order to use a message-driven application or an event-driven architecture. It's a very nice pattern that has a lot of benefits, but it's not a requirement. And all of these things together creates a, well, a pretty gosh darn stable system. Oh, well, stable maybe is a strong word, but this architecture, it works pretty well, I would say. But that's just based on my experience. Have a great day.